Welcome back, everyone. In this video, let's learn about the Reselect library. So first, we need to add the Reselect library into our application. While this is fetching, what I'm also going to do is I am going to restart the server, because once this is installed, we need to make sure that our server has the latest libraries. This is most likely the most common time when you want to restart your development server, is when you know you have new libraries. So I'm just going to rerun yarn start here, and then I'm going to go back to my application, and I'm going to explain to you how Reselect works. Now, the basis of Reselect is that it creates for us this concept of a memoized selector. So let's talk about what a memoized selector is. Memoization is the process in which you cache the previous value of something, so that if the input has not changed, then you just return back the same output. This works when you have a pure function. For example, if we had some function called add, which takes some value a and b, and it returns you a plus b, we know that because this function is pure, if we call add of 3 and 6, this gives us back a value of 9. If you call add 3 and 6, does this mean that you need to run a plus b every single time? No, of course not. You know that if you receive the same input, because the function is pure, you should always get back the same output. So why waste the extra resources to recalculate something that you already have calculated before? Memoization is that extra step inside that does that for you. So create selector does that with selectors. It memoizes them, assuming that as long as the inputs have not changed, then your output should always be the same. Now, how do we extend that into selectors? The way it works is that we have to create what are known as input selectors and output selectors. Input selectors are selectors that give us the parameters that we need in order to determine what our output should be. If that sounds confusing, I know it absolutely is. Let's write some examples so we get an idea of what we're doing. First, what I'm going to do is I'm going to create an initial selector that gives us back just that slice of the reducer that we need, which is the category reducer. So here I'm going to say select category reducer is equal to some function that receives the state. It's a selector function. It gets the entire Redux state. And then from this, we just want the categories slice of the Redux store. Next, what we're going to do is we're going to use this inside of a memoized selector. So in order to create a memoized selector, we need to first declare what it is. So this is select categories. Select categories gives us back the categories array that lives on the category slice of our Redux state. So here, in order to select this, we have to say, hey, I want to use the create selector method. This method creates a memoized selector, and it takes two arguments. The first is an array of input selectors, and the second is going to be the output selector. The input selector is going to be, what do I want as part of the parameters that I'm going to use to produce what this selector should return back. So what are the slices that I want from Redux so that I can use them to produce something new outside? Here, I want to get the categories slice, because off of the categories slice, which we will receive as the argument inside of the output array. So whatever this is, whatever the output of this will be the argument that is in the same place inside of the output array. So if, for example, we had another selector, let's say it was select current user, this output is going to now be the second argument of our output selector. But we only need, of course, the one for this. So now we're going to take categories, and we're going to say, okay, you know what? Actually, let me rename this category reducer so that it's more clear. Or category slice. I like that more. I want to take category slice, and I want to get off the categories value. Now, this selector is a memoized selector. The only time where this will run is if this category slice object that we get back from this selector is different. Because if this input value of categories is different, only then does Reselect determine, oh, we need to rerun this method. If this categories value is always the same, again with the strict equality, triple equals, then I know that the previously cached computative value is going to be enough because these functions are pure. So as long as this categories object is always the same in memory, which it will be as long as categories reducer has not updated, then that means now suddenly this value will always be the same one. Now this becomes extremely powerful when you think about what we were trying to do with our categories map. Because we didn't want to run this reduce if categories had never changed. So in order for us to memorize this, all we need to say is that, hey, I'm going to create a selector here. And this selector is going to receive select categories. Here you can notice they're composable. If we pass this structured selector in as the input, it will in turn memorize here already and then memorize here again. So now we know that we're getting the categories, which is the categories array. With this categories array, I want to, of course, reduce over it. So I'm going to copy this over. And now I can get rid of this code. Fix this typing here. And now I've created a memoized selector for this mapping that I've made. What's happening here is that we're saying, hey, as long as the categories array does not change, do not rerun this method. Of course, you want to reduce once, but after that, as long as it has not changed, don't even bother rerunning it. Just give me back the previously calculated value. And because the previously calculated value was the previous return of reduce, which is an object in memory, what you'll notice is that useSelector now works. That triple equals is going to see, hey, that previously cached value is actually the same value, the same categories map now. Unless the categories array value is different, then what will always happen is we'll just get back the previously generated object. In fact, to prove it to you, I'm just going to add an additional console log here so that we can see what happens when we relook at our flow. I'm going to say selector fired so we know that we're firing our selector. If I go back to the application, I want to clear this out. I don't want to talk about the initial mounting step yet. I just want to show you what happens if you remember. Previously what happened is that we would sign out. This triggers set current user. Set current user updates our Redux store. And of course, because our Redux store is re-rendering, our selectors get called from the use selector hook of React Redux. This in turn will do the equality check and see if there's anything. Before, we were noticing that our components were getting re-rendered because we were not being able to properly do the check due to the reduce call. But now if we sign out, what do we see? We see set current user gets called. We see that our payload gets called. We see that our current state is getting updated, but this is all within our logger. We're not actually even seeing this component getting triggered. Now, why is it that our selector didn't even fire? This is because we didn't even make it this far into this select categories map. This select categories call here didn't even run. It just returned what was already cached, which is an output. And the reason for this is because, of course, once again, this is all memoized. If we even go up here and we say, hey, is this even getting called? So I'm actually going to be more specific. Selector 1 here, this is selector 2. If I save this, and I come back here and I refresh, let's re-trigger our flow, sign in, clear out. If I hit sign out, still, you notice, I'm still not even getting our selectors. The reason, once again, is because this is also a memoized selector. This selector is actually the only one getting run, and this one is in itself what is being cached at this input level. So now if I move this console log up here, set this one to selector 2, and then this one to selector 3. If I save, let's reset up our application, clear this out, refresh. let's sign out. Now we see selector 1 fired. That's as far as it got. So inside of our category component, when current user got updated and our user selector updated, of course, all used selectors are getting fired. Select categories map, as far as it went, was it determined, hey, what's the current value of categories? Now, categories is output from our category reducer. This object, of course, has not updated. Only the user reducer has updated. Therefore, it doesn't even determine the need to fire this logic, let alone this logic. It's just going to take what was returned from the last calculation of this entire composed chain, which was the previously calculated reduced down categories map. And it just returns that as the value. And that value, of course, is the same value that the useSelector had previously. Therefore, this category component does not re-render. Now, if that is confusing, I understand. We learned a lot today. But really, this is one of the most powerful aspects and why the Redux ecosystem is so fleshed out. Because React is constantly going through this re-render battle. All of these elements, all of these steps that we're taking are just all of the ways that we scale out a Redux application. Every single step that we're doing here is a different way that all of the different tool makers and this Redux ecosystem has developed because of this separation of the logic. We want to make sure that in our selectors, we have all of our business logic. But at the same time, we want to make sure that we're not messing with any of React's own re-render cycles. So there's all of these tools that were really thought out and very careful and intentional about how this all works together. But hopefully here now, through this flow, you saw what we were doing. We now have mem-wise selectors, which are very intelligent in being able to determine, hey, if nothing's changed, just don't even bother re-rendering. So let me get rid of all of those console logs, because now we have a working example of our mem-wise selectors. There we go. So hopefully you learned a lot through this process of migrating away from the categories context into category reducer. There was a shifting of the logic, the architecture, and a lot of these additional pieces that we learned in order to fully flesh out our understanding of how all of these different pieces in Redux play together and how we can optimize it. So if this was challenging and confusing, redo this yourself. Because only through that process and just console log every step of the way in order for you to really understand what's happening in these interactions. I know it's really, really challenging. Redux has a very notorious reputation, as I've mentioned, for having a very steep learning curve for this exact reason. There's so much boilerplate to set up. There's all of these additional libraries in the ecosystem that help us to understand what's happening. But the benefit, of course, is the unidirectional data flow that we get with this type of architecture. So now that we've done this, my challenge to you is to migrate over the remaining context to Redux. And that context, of course, is the cart context. So do that, and then in the next video, we'll do it together, and I'll see you in the next video.